Black-Scholes-Merton option pricing model. Derivative pricing in Python. The Black-Scholes-Merton model is one of the earliest option pricing models that was developed in the late 1960s and published in 1973. The most important concept behind the model is the dynamic hedging of an option portfolio in order to eliminate the market risks. First, a delta-neutral portfolio is constructed, and then it is adjusted to stay delta-neutral as the market fluctuates. Finally, we arrive at a partial differential equation for the value of the option, where V denotes the option value at time t. S is the stock price. Sigma is the stock volatility and R is the risk-free interest rate. The equation is also called a diffusion equation, and it has closed-form solutions for European call and put options. For a detailed derivation, and analytical formula, see John Hull's textbook entitled Options, Futures, and Other Derivatives. In this post, we focus on the implementation of the Black-Scholes-Merton option pricing model in Python. Closed-form formula for European call and put are implemented in a Python code. The picture on our website shows the prices of the call and the put for the following market parameters. Stock price, $45. Strike price, $45. Time to maturity, 1 year. Risk-free rate, 2%. Volatility, 25%. We compare the results to the ones obtained by using third-party software and notice that they are in good agreement. In the next installment, we will price these options using Monte Carlo simulation. Go to our website to download the Python program.